All right, guys, today is day 2 of the 113 notes. Again, we're going to be jumping all over the place. Actually, I don't even know if I'm going to be using that much of the book, but 113 notes starts on page 39, but again, I'll be all over the place. Today, in this video, we are only going to focus on one thing, and that is learning the 5 function families, which are linear, exponential, quadratic, absolute value, and linear piecewise. I'm going to show you examples. We're going to talk about some characteristics, and we're going to have a good idea of what the equation should look like. So hopefully by the end of this video, you will know all 5 of those function families and what they look like. All right, we're going to start with the linear function family. And if you look over here, linear means a straight line. And my first example that I'm pointing out right here is increasing. As I start from the left and I go to the right, it is increasing. There is no vertical line of symmetry because it's not the exact same on both sides. And there is no horizontal line of symmetry, okay, on this example. There is no maximum and minimum. Again, if I was looking for the maximum or the highest point, I can't because this one goes on forever and ever up and to the right. And there's no minimum because it goes down forever and ever to the left. So this example has no maximum or minimum. If I look down here at this example, this one is decreasing as I go from left to right. So this linear equation would be decreasing. This example has no vertical axis of symmetry and it has no horizontal axis of symmetry. This example also has no maximum because, again, it goes up and to the left forever and ever. And there's no minimum because it goes down and to the right forever and ever. Down here at the bottom, you could say f of x, function of x, which means x is your independent variable. Or you could just say y equals. So f of x equals ax plus b, where the a and the b, I wrote them in green. Everything that's in green down here are actual numbers. So when you see it, an example might be f of x equals, and I'm just going to make up a number, 4x. It could be plus, it could be minus, so I'm going to say minus 5. That's an example of what a linear equation would look like. Now over here on the right, we're going to learn about the exponential function family. This example right here is decreasing because it starts off up here and it's going down as it goes to the right. So this one is decreasing. There is no vertical axis of symmetry. There is no horizontal axis of symmetry in this example. This one also has no maximum minimum, just like linear. Up here, if I keep going up and to the left, I can never find the highest point. And if I'm going down and to the right, now I know it looks like it levels off, but we'll get into this more in depth later on in the year. But it's going down and to the right, so there is no minimum value. If I look at the next example right here, this one is going up as I go from left to right, so this one is said to be increasing. There is no vertical axis of symmetry anywhere, and there is no horizontal axis of symmetry on this example. There is no maximum, because again, I cannot put my finger on the highest point because it's going up and to the right forever and ever. There is no minimum because it's going down and left. And again, I say this a lot. I know it looks like it's leveling off. It is not. We'll talk about that later, but it's going down and left, so there is no minimum. Now down here, f of x equals, and again, everything written in green is going to be a real number. So you're going to have an actual number for a, b, and c. Exponential functions has an x right here as an exponent. Okay, so that's your key feature. Whenever you see an equation and you see x as the exponent, that's when you should immediately start seeing like a little red flag and go, oh my god, this is going to be an exponential function. All right, the next function family we're going to talk about is absolute value, and it is very closely related to quadratics, and I have well, not really closely related. A lot of kids get them confused. Absolute value is made up of 2 straight line segments here, or rays if you are in geometry. So they are very, very straight. They are both linear, whereas over here, quadratics have a curve to it. Okay, so don't get that confused between absolute value and quadratics. Now, this example up here at the top of an absolute value, it starts off decreasing as you go from left to right. It's going down. So it's decreasing down to this point right here, which is the minimum point. It's at the lowest point. So I can put my finger on the lowest point. So it is decreasing down to the minimum, and then it begins increasing as well. Now, this one does have a vertical axis of symmetry. If I would have drawn it really well, this is not that well, but it has a vertical axis of symmetry right here. It does not have a horizontal axis of symmetry, but it does have a vertical axis of symmetry. This example down here, if I start off on the left and I go to the right, it is increasing because my hand is going up. So it's increasing to this point right here, and this point is called the maximum because it's the highest point. And then from the maximum, it is decreasing, going back down. So again, increasing to the maximum and then decreasing. This one does also have a vertical axis of symmetry. It does not have a horizontal axis though, so it has a vertical axis. And if you look down here at the bottom, by the way, these are absolute value symbols. I slightly slant mine, and you're going to see this all year long. I slightly slant them so that you don't think they're the number one. In your math book, they're straight up and down though. Okay, and I tried to put a little arrow at the end of this video so that way you can see it. But f of x equals a, b, and c are going to be real numbers. Okay, now let's move over to quadratics. Quadratics, again, if I start on the left, it is decreasing down until this point right here, and this is the lowest point. I can put my finger on it, so that's called the minimum, and then it's increasing again. So again, decreasing to the minimum, then increasing. This one does have a vertical axis of symmetry. It does not have a horizontal. The bottom example, this one, if I start on the left, it is increasing all the way up to this point, and this is the highest point, so this is the maximum, and then it is decreasing down. So again, increasing, maximum, decreasing. It has a vertical axis of symmetry right here if I drew a line straight up and down, but it does not have a horizontal. And the equation for it is down here where a times x squared plus b plus c, a, b, and c will all be real numbers. You may see plus or minus symbols right here. We just put plus to save some time. All right, our last function family is linear piecewise, and we're not going to spend a whole lot of time on it in this section. We'll get caught up on it later on in the year, but I do want you to be aware of it right now. And the example I have right here to start off looks like it is increasing, and then increasing again, and then increasing again. This one has no vertical line of symmetry, and this one has no horizontal line of symmetry. And this example down here is also considered linear piecewise. It has closed points, which means it's part of the line. It has open points, which means it is not part of the line. So open point, not part. Closed point is part. Now this one is a function, because if I were to draw a vertical line right here, it is a function because that closed point means it hits right there. It's part of the line. But this open point means it does not hit because that open point is not part of the line. So this one is still a function. Now, to give you an idea of linear piecewise, you probably are aware of this more in real life than you realize. If you've ever bought shirts online, or if you're part of a team and they bought shirts, here's an example of linear piecewise. They might say something like, if you buy between 1 and 10 shirts, we're going to charge you $20 for every shirt plus $5 for shipping. If you buy between 11 and 20 shirts, $15 each plus $8 shipping. And if you buy more than or 21 or more shirts, it's $10 each plus $10 shipping, because the more you buy, the heavier it gets, the more they got to charge you for shipping. So if I was to set up equations, I might say y equals, or if I'm using functions, I'm going to say f of x equals, and I'm going to do the first one up here. Between 1 through 10 shirts, it's $20 each plus $5 shipping. So I'm going to say $20 times the number of shirts, and x is the number of shirts, plus my $5 in shipping. The second equation, f of x equals $15 each, so 15 times the number of shirts, plus $8 shipping. And the third example, f of x equals $10 each, so 10 times the number of shirts plus $10 shipping. Now, if you guys can see, I have f of x equals, f of x equals, f of x equals. That's a lot of wasted writing. So what mathematicians did is they said, hey, we're going to save ourselves a lot of time. Instead of writing f of x 3 times, we're just going to write it once. So f of x equals the top equation, f of x equals the middle equation, and f of x equals the bottom equation. Now, I have 3 equations, but we need to specify when do we use each one of the 3. So what we have over here is the domain. So I'm going to give you an easy example here when we're using this. I'm just going to write it. Try not to confuse you, because I don't know how many of you guys have worked with inequalities. But the top equation, I'm going to say from 1, including 1, all the way to including 10 shirts, we use this top equation. So if you order between 1 and 10, you use the top equation. Now, if you order between 11 and 20, so again, I'm going to include 11, so that's why it has the or equal to, and I'm going to include 20, and it's why it has the or equal to. So if you order between 11 and 20 right here, you're going to use this middle equation. And if you order 21 or more, so if x is greater than or equal to 21, you're going to use this bottom equation. So this is what linear piecewise would look like. But again, you're not going to see it on your homework tonight. We're going to save that for more in the future down the year. Okay. So again, hopefully you understand the 5 function families and you understand a little bit of the characteristics about them. All right, now on your homework tonight, it's going to be starting on page 61. We are doing the right section, so you have to match up using these definitions right here with 1, 2, 3, 4, 5, and 6. We are not doing the remember, but we are doing the practice problem 1, and if you need to graph it, use Desmos.com if you don't feel comfortable with your graphing calculator. We are not doing number 2 because that is the linear piecewise, and I'm going to save that kind of information for later on in the year. All right, on the next page, here's practice problems 3, 4, and 5. And again, you might want to use Desmos.com. And here's what I'm talking about. These symbols right here, a lot of kids got them confused last year and they thought they were the number 1, but those are absolute value symbols. Okay, so absolute value symbols when you type them in. We are not doing the stretch, but we are going to do the review problems 1, 2, and 3. Review problem 1, identify the axis of symmetry. I just want you to tell me if it's vertical, horizontal, or if it has no axis of symmetry, and then tell me the number of quadrants it goes through, and then solve 2 and 3 down here. All right, good luck.